Hello, welcome to Earthly Show and Tell. Today I have Dan here. Dan, why don't you introduce yourself and tell me what you do, who you are?
Hi, I'm Dan. I'm a software engineer at Replay, doing all sorts of things because it's a small company. But one of the things I did early on was straighten out our build process and build a lot of the first developer tools beyond just a series of commands to run in a markdown file. And real quick on Replay, Replay is a debugger, a time-traveling debugger for the web. So unlike traditional debuggers, you can set breakpoints, and when you set a breakpoint, you can see, let me do that real quick, set a breakpoint. And normally you set a breakpoint like, oh, I have to seek to it. But with Replay, you instantly see all of those breakpoints being hit simultaneously. So this is every time that line of code was run, and we can change what this breakpoint says. I'm like, what is ancestors? Save that, and it instantly gets evaluated, and we can see what ancestors is at every point that this line of code is run. So there's not lots of services relative to some companies, but there are services. There's distributed systems problems, and crucially, doing this requires a lot of computational power for even, like this replay is 5 seconds long. That's probably not so bad. But even for a 30-second replay, it's possible that it would be prohibitively slow to run all of this on one laptop. And so we have to do a lot of our development in the cloud, which involves building lots of code, building Docker containers, shipping it up, and iterating on it quickly.
What's the stack? Like, I know you got C++ and...
Yeah, so we have a fork of Chromium, which enables a lot of these time-traveling features. And that fork of Chromium is used by end users to create and upload replays, but it's also used on our back end to replay the replays. And there's a little management service that sits on top of that that's written in C++, and then there's another service that sits on top of that written in Node.js, and then there's sort of an API layer that is multiplexing across all these different Docker containers, each of which could be running many thousands of Chromium instances.
Oh, wow.
So yeah, one recording is, if it's of sufficient length, will be powered by multiple different containers, each of which will have many, many, many Unix forks of Chromium hanging around waiting to service your request. So when you ask about this line of code, we fork Chromium 16 times, one for each of these, so that when you evaluate here what child is, we can kind of do like a MapReduce style thing and get those results really quickly.
Wow, that's huge. Like,
it's really powerful. I feel bad because when I write a lot of C++ code, a lot of Rust code now, and this doesn't work for those tools yet. So it does feel like stepping back into the Stone Ages when I don't have Replay.
so I think you guys have a pretty interesting like dev setup. Maybe you could walk us through that.
So here we are. Yes, here's me. I'll make this bigger. We use a tool called Tilt. Tilt is kind of like another build tool, but most build tools are concerned with taking files and turning them into different files, whether that's take your C++ code, you turn it into .o files, or you take a Docker file and you turn it into an OCI image or something. Tilt is more concerned with files are changing, builds are happening. I'm not super concerned with how the builds happen, but then I want to run the code. How do I reliably run the code after the user has changed something? So it's sort of like a really souped up version of NodeMon or Grunt or tools like that. Tilt is declarative, like Kubernetes and like some other build tools, and is actually written in Starlark, like Bazel and Buck and things like that, which is a dialect of Python. And so you declare your Docker images and how they're built. You declare your things that are running in Kubernetes, and it automatically determines that those two things are dependencies of each other and knows that when files that go into the image change, to rebuild the image, and when the image changes, to redeploy the deployment or the cron job or whatever you have. So this file is a little bit of a mess, But down here, we can see all the different services we have. We have this thing called agent, dispatcher. This is saying like run Helm, do all of this Kubernetes stuff. But the cool part is that in this YAML file, we specify an image name, which I think is literally just like agent. And so if we have this, what do we call it? Earthly build. Yeah. Or it's like a AWS ECR thing. And if we look for, let's see, I think we can just do /agent probably. Yeah. There we go. We say, hey, look, we're going to build an image. It's going to have this name. It has some other arguments to it. We inject the name of the image. So the way that Tilt keeps track of which images have been built is it wants you to build an image with the name that it gives you. And Earthly allows us to do that. So we pass in this expected ref thing as a build arg. I'll show you how that works in a second. And then we specify all of the files that when those files change, we want to rebuild this image. So that's the Earth file. It's a couple other big shared libraries, and then it's the agent code itself.
So it's like you working locally here, you have files, you're running Tilt. Tilt's like running, and when it sees a change, it calls Earthly. Earthly pushes to ECR, and then what happens? Then Kubernetes pulls it in place. And
so yes, what happens is that I change a file. So like there's source agent main, right? That's imports a bunch of stuff and then just starts a web server basically. And if you change this file, Tilt knows, okay, source agent is a directory, and that is a dependency of this image. I'm going to rebuild this image. It also knows that if we look for this image name, probably in the rest of our code, yep, that it is used in the agent Helm chart. And so it can infer that connection. And so it knows, well, if I've built that image, then I'm going to redeploy this Helm chart, and I'm going to override the image name to be the image name of the one I just built. And that comes from this expected ref magic here, because Tilt told us, hey, build, and it's going to be the name of your image, :tilt dash timestamp, basically. Build this image, and once you claim you've built it, I'm going to check. And if it's actually there, then I'm going to proceed and tell Kubernetes to update to it.
Very cool. So this is local. Tilt is running locally. Kubernetes, is this like, do you have your own Kubernetes?
Yeah, so that it's just that AWS managed Kubernetes. And yeah, real quick to go down a bit more of the Earthly stuff. So Earthly build is a little function we wrote. It wraps the real Earthly. It sets some environment variables. It uses satellites. This is basically only disabled when we have some sort of weird outage or I'm trying to upgrade the satellites. And then it runs an Earthly command. But there is one neat trick here, which is this --no output --push, which means because we're almost always running in a satellite, the effect this has is instead of having your build, I always get these confused, build kit container running locally on your laptop and building the image there and then pushing it up, which is probably, at least for us, going to be 700 megabytes of Ubuntu to push up. What this does is it sends, effectively, it sends only the diffed files that need to be sent up to the satellite. That's probably tens or hundreds of kilobytes of text. The satellite builds the image. The satellite pushes it to Amazon. And that's it. Your computer basically did nothing at all. So the effect for our users is that builds are really fast and your laptop fans don't spin up. Even though we live in this blessed age of Apple Silicon laptops, for our poor coworkers still on x86, building Docker images is like actually legitimately painful on your lap. And this bypasses that completely, and it's way faster because the time it takes for the Earthly folks to send an image from their servers to Amazon is way less than it's going to take you even on a super high bandwidth fiber connection or something.
That's awesome because, yeah, I mean, spoiler alert, we're also in Amazon.
Yep.
So, yeah. So I feel like we need to break this down because this is your local development. Tilt is running locally.
Yep.
Earthly is being backed by a satellite that is
Yep.
remote. And then it's pushing to Kubernetes, which is also in AWS. And then so when you do your local dev, you're connecting to this remote environment.
So this is Tilt, and Tilt allows you to kind of bundle all of your development workflows into one system. So the obvious developer workflows are, I changed some code, I'm going to build it and push it. That's easy. But there are other pernicious developer workflows like, how do I use this thing? What URL do I go to use the thing I just set up? You know, even on your computer, that's annoying. You're like hunting around the logs, like, where's the local host? Like, is it 8080? Is it 8081? Is it 3000? So Tilt allows you to specify, again, in this same Tilt file, like, hey, port forward from port 8000 on my laptop to port 80 on this service. And those things get exposed in the Tilt UI, which is really nice. You can click on something and see, like here, localhost 8000. That's, if I want to talk to this agent, which is running in the cloud, I can do it as if it were on my laptop, just through port forwarding. No crazy magic there. No like VPN going on or anything like that. But also, you can specify other workflows. So we have these things up here, like replay browser and view latest recording. So this is sort of like the write and the read operations when you want to use this cluster you just brought up. How do I view recordings in my dev environment, and how do I create them? And you create them by using the replay browser, and you view them by clicking view. But these are also defined in here. So we can like search for replay browser. This is like a local resource. So it just runs a command on your laptop. The browser command, it runs npx. It sets some environment variables. It tells it, hey, use localhost 8000. Instead of, you know, api.replay.io:443, which is the default. So then you can just click this button here and everything gets wired up for you. You don't have to worry about which environment variables do I have set and have I built the correct thing. It just does it all for you. And the same thing with view latest recording. I think it's actually, also does an npm thing, sets some environment variables.
It's like a nice developer experience play. You're like, listen, it shouldn't be this complicated to get started. What if we have like a dashboard that they can start up with all the services?
Yeah, or like a menu is how I've thought about it. Sometimes you want to order off menu, you're feeling adventurous, but a lot of times people want the same stuff. And if you can make those paths, the happy paths, make them really obvious and easy, then you avoid the issue. Like I've had a lot of companies where you ask someone, hey, how do I test out a database query? And everyone has a different answer. Like, well, here's my script that does it. And I use PSQL and I do this. And then someone else is like, oh, well, you can log into Metabase and run it over here. And this is like, no, there's the one true path. We've socially, as engineers, we've all agreed on it. We've iterated on it. We've added features. And so it becomes well known. And it's not explicitly tested, like unit tested in our case, but if this breaks, everyone realizes because everyone uses it. It's so convenient. You just click the button and it pops open the browser with all the environment variables set up.
Yeah. And it's in source control. So people can see it, change it, complain when somebody messes with it or breaks it.
Yep, exactly. Yeah.
Something that came to mind with your setup is like there's a architecture mismatch, I assume, if you're running the Apple and deploying onto a x86 cluster or something, right?
Yes. So we set this right at the top of the earth file to avoid that problem, which maybe there's a better way to do it, but that's what we do.
No, it makes sense because I was thinking, my MacBook is fast, but if I'm building a container to deploy on x86, I have to like run an emulation.
Yeah, you would know better than me what's going on there, but I imagine that is slower. Yeah.
Yeah. It is. So it's basically, it just runs an emulator and then builds it in that. So it'll work fine wherever you deploy it, but you have that overhead of emulating a CPU rather than actually running on one.
Yep.
Cool. What else interesting do you do? What What can you show us?
Yeah, so I mean, this is kind of a great segue. Now we're in the Earth file. I think and maybe we start at sort of the top, which is we've been using the agent as an example. Here's the agent target in Earthly. It looks almost exactly like a regular Docker file at this level. Running some commands, setting a bunch of environment variables. The only thing that looks weird are these copies with the plus signs, and we can run if statements, which is awesome. This plus sign is a reference to another thing in Earthly. So if we command F esbuild agent, see, esbuild agent. We have these like common deps for things we need when we run esbuild. We copy in all the dependencies we need for the agent. And this looks funky and weird. What's this? This is user-defined command. Is that what we call it? Basically a macro.
Yeah, we've renamed them commands. They used to be user-defined functions.
User-defined functions. Okay.
Or no, they were user-defined commands. Now they're commands. I hope I'm getting this right.
But basically a macro. So this expands. Wherever you use this command, it expands into this. And it's just, really we wouldn't need it except that because we are mostly running Node.js for a lot of the code that people change day to day, we have to deal with source maps. And so we have all this logic in our esbuild thing where if we're in production, we want to make sure we upload the source maps. And if we're in production and that fails, we want to exclaim loudly that it failed. Otherwise, we sort of just brush past it. And Earthly allows us to express that stuff. And I guess another thing is that I'm realizing looking at this is this esbuild.ts file. It's just the build script, right? But this existed before Earthly. And when we moved things into Earthly, we didn't have to change anything about it, which
cool.
is one of the great perks of Earthly is a lot of build tools. Well, when we were at Tilt, the CEO of Tilt had this great phrase called Mr. Rogers onboarding. Mr. Rogers would always say, I like you just the way you are. And a lot of build tools do not like you just the way you are. They're like, well, if you're going to use me, you have to like structure your files in this way. You got to set up all these YAML files. You got to do this. You got to do that. You can't depend on everything has to be pure, deterministic, hermetically sealed things. Earthly does a great job of striking a balance of giving you a lot of the speed up benefits you can get from more fine-grained dependencies and more hermeticity. Is that the word? In your builds, but it doesn't mandate it. So, early on, this probably looked more like copy in all of the source files, run esbuild 8 times, one for every bundle we want to produce, and then save them all out. And that works just fine. It's a little bit slow. It's nice to be able to cache these things individually. Then you have to think about like, well, okay, which files does the agent esbuild bundle actually depend on? But it allows you to move along that spectrum as you A, want to, and B, can, because a lot of times, sadly, we are not paid to just make our builds as fast as possible as, or maybe at Earthly you are, but I'm not, unfortunately, as much as I would like to.
Yeah, I feel like every company, somewhere they have a build that's just like a mess, and there's reasons that it's a mess, or it has like complicated things. It's not easy to pull apart.
Yes.
And yeah, there is great solutions where they're like, the way you're building things is fundamentally unsound. Let's rethink it from first principles. But sometimes you gotta work with the real world. I like that Mr. Rogers thing. That's great. So what happens next? We esbuild.
So yeah, that esbuild -agent thing does the esbuild. It says I'm going to output this agent.js thing, which gets saved as an artifact from this rule or target. I don't know. What do you call that at Earthly, actually?
A target.
Target. So this target has now out/agent.js as a thing. And when we look at the agent image, we see, actually, this is another great thing about Earthly. We can just copy everything from out. We don't have to specify, like, I want exactly agent. So it's just like, nope, whatever's in there, we're going to grab it. We're going to stick it in the working directory. And then it's just like a normal image. Eventually, we tell it what command to run, and we push it.
Nice.
So yeah, that's the That's the like running a service side of things. But the cool thing about Earthly is it can do anything really. So we also have like our C++ builds in here for at least the non-Chromium C++ stuff. That's fine, you know, get a GCC, do whatever you want. And at least this is one of those examples actually where it would be nice if, you know, we broke these out into separate individual compiled units.
Oh yeah, to get some better caching.
Did
maybe.
some better caching, but right now we just run this every time, and it's kind of a bummer. But hey, it only, you know, again, this build linker script existed before Earthly, and I just call it. I did do a little optimization here where we inject the date into the code so that it has like a build date so that we can put that in error messages and stuff, which is convenient, but blows the cache every 24 hours. So I did break that out into its own target, which just builds a little C++ file so that at least we don't have to rebuild this literally every time.
So it just blows the cache on that one linker version task?
Yes.
Yeah, that's tricky. That's the place where the hermeticity gets tricky when you have dates.
Yeah, and, you know, there's a reason for that. The reality is that this cannot be cached for more than 24 hours ever, but we change it once every couple weeks. So yeah, we're eating a cost for that convenience, but Earthly allows us to do that. Something like Bazel or Buck, as we're learning, forces you to reconsider that, which is good, but is sometimes not what you want to be spending your time doing right now.
Yeah, there was a time I was trying to describe Earthly as glue, being like, well, you got all these things, let's glue them all together. You know.
Yeah, and when you first start learning about build systems, like build systems are Make and they're Bazel. But really, when you start to look at it, build systems are everywhere. There's NPM is, of course, a build system, so is Maven. But all of these languages and platforms have their own build systems. And for example, it would be pretty painful, but possible, to be like, you know what? We are a company that makes a debugger for JavaScript, so we're all in on JavaScript. All builds are going to go through NPM. And we could build C++ code that way, but it would be terrible. But it would be nice because then it's like, well, everything is an NPM install away, and it would be a convenient UI for your UX for development. And Earthly allows you to glue these things together and be like, well, it's unfortunate that we haven't standardized on an amazing build tool that works across all languages and platforms, but Earthly allows us to pretend that we have. And so whether you're building just a little JavaScript bundle that you're going to run on your laptop or you're building C++ code, it's just Earthly plus whatever. And you don't have to worry about the specifics of how that's happening.
And you're working in JavaScript, maybe you don't want to know how the C++ parts.
Believe me, you don't.
Yeah.
And I think it is also another nice thing about Earthly is there's a lot of cultural differences between JavaScript programmers and C++ programmers. Also a lot of similarities, but a lot of differences. But Docker and containers are one of those things that those two groups are more likely to at least be somewhat familiar with. If you're doing client work and building websites, you've probably downloaded a Docker container and used it to run stuff before, if nothing else. If you're doing C++ code, you've worked at companies in the past couple of years, your code has probably ended up in Docker containers, and you've become a little bit familiar with that. And it's nice to have Earthly as a Earthly the syntax as a familiar-ish lingua franca for people to talk about, where anyone can like open up this file, and if they've seen a Docker file before, reason through what's happening here. It's like, okay, I'm copying a bunch of stuff. I run exactly one command, and a bunch of stuff comes out.
So we covered a lot of stuff. I don't know, is there anything else interesting about your setup you want to go over or share?
So you could imagine your first Earthly rule is just like, build from Ubuntu latest, whatever, copy everything. I don't think the syntax is exactly right, but imagine that, and run make.
Yeah.
Save this, and like, boom, you're done. Now, you can start to break this down. People can start calling build. Maybe eventually this becomes a couple weeks later something like this, where instead of just calling this, you're like, well, we build the website and we build the API and etc. And your users don't have to realize. So you can start small, give yourself this little container that's wrapping things. It's, well, let's not use latest. Let's at least do this. All right. What even is Ubuntu? Is this new? I don't know. At least do this. And then you can like, all right, at least we know that everyone's running the same version of Ubuntu. We don't have to worry about the differences between BSD grep on, Mac and GNU grep on Linux. Everyone's using the same thing, and then start to optimize from there. And at that point, your users don't have to know. They're just calling build. And that gives you a lot of flexibility to try things out. So that's one thing. Is I think it's easy for engineers to get really excited about making things really fast, but as long as you wrap things in a good interface and push it out, you can make those performance optimizations later. And when you push it out, you'll find out that the things you thought would be slow aren't. And there's this other thing that you were not thinking about. So be like, iterative and kind of quote agile, get something out there, find the bottlenecks that are hitting actual people and work on those things. And Earthly allows you to do that because you can just take whatever your build tool is, stick it in Earthly, and now you, as the person working on it, can iterate, and none of the other teammates need to, their day-to-day isn't changing in terms of the kinds of things they have to do. It's just hopefully changing for the better, as they don't have to like install 26 different things on their first day to get all of their homebrews set up exactly right. And then hopefully their builds start to get faster too. I'm a big proponent of satellites and building stuff in the cloud in general. A lot of, Macs are great. I love Mac OS. There's a lot of reasons why building software for Linux, which is often our target, is slower. Even if it's not Docker images as your ultimate target, you're just doing binaries that you're SCPing up. Even that can be a little bit slower because of cross-compiling stuff. So I'm a big fan of doing things like that. I'm also philosophically a big fan of, I think it's nice to be able to say, I'm going to run my API layer in isolation. I think that's nice. I think it is always necessary to be able to run everything. Like have a branch, run everything from the website down to whatever the state of your database will be. And so having that as one of your DX targets, like we have, I don't know if it's a KPI or whatever, we have a goal that someone within 10 minutes should be able to spin up the entire app in isolation, is I think really important, because there will always be bugs that only occur at the intersection between two services. And it's really frustrating when debugging that is difficult. And I think also you should be able to just spin up the API layer and poke at it with curl. But I think you really do want both. And so, but running a bunch of services on your laptop can be taxing, even if you're not all in on 3,000 microservices. 10 can also be annoying. So having the cloud there is great, and it's way faster too. Like I think it's kind of a win-win. And tools like Tilt and Earthly make that way easier, because you're not shuffling all these bytes around. You're just sort of orchestrating things that happen in the cloud. You're sending hundreds of kilobytes instead of hundreds of megabytes of stuff flying around.
Yeah. I work somewhere, and there was like, I don't know, less than 100 services that made up the app, but a lot. And so you would end up, you just didn't do that. You didn't start up the whole thing for your branch, right? You started up like the thing you were working on and like pointed it at this like staging thing and hoped that it all kind of connected. And then if it was a mess if you had like queues or Kafka and you're trying to make,
Yeah, and the counter argument is that that's a lot more work to implement. It's a lot more work for the computers to do wherever they are doing them. And it is undeniably slower to build 10 or 100 services and deploy them than it is to build one. And I totally get that. My point only is that, like, even if you only need that once every couple of weeks, if when that time comes, it takes you a long time to spin that up, or more likely what I've seen, the person's like, whatever, and just like, we'll do it in prod, which is, sometimes you have to do it in prod, but that will lead to more issues and stress than if it's like, well, I'm going to, set my tilt on full blast. It's going to build everything. I'm going to come back in 10 minutes and I have a little sandbox I can play around in. That's way less stressful.
Yeah, that's awesome. This feels like a tangent, but super important. Like, how do you guys actually do this? So what's in that cluster where Tilt's deploying things to? Like,
yeah, so we have 2 AWS accounts, one for things that users interact with and one for everything else. And when you run Tilt, you're interacting with the everything else category of stuff. And so in the Tilt file, it's everything from that point on is all in the Tilt file. So like, I forget exactly where this is, but we changed the Kubernetes namespace basically depending on who you are. So that's our unit of isolation. There's some things that doesn't quite work with, like infrastructural daemon sets that are doing like log shipping. That stuff is still hard to test because you can't just have everyone have their own log shipper running on every node shipping logs all simultaneously. But for most of the stuff that we're changing most of the time, like our actual application code is completely namespace isolated. And so
what about data-y stuff?
Yeah, so that gets tricky. We used to use this tool called Snaplet. Shout outs to Snaplet. They are great. The dream is that you can snapshot your database, your production database, anonymize all the PII, and then pull that into your development environment. At some point, our production database grew way too large for that to be feasible. And so the stupid way we were doing it no longer worked. And so now we're just running on a 2-year-old fork of our production database with anonymized data, which isn't ideal. But yeah, in dev right now, databases are shared. And that is something we are actually having a meeting to talk about on Friday because it has started to cause some problems. But if I think for a lot of people, well, I think there's still room for some startups out there to make this problem better. There's the PlanetScale DB has a really cool approach to this if you can use the MySQL sort of wire protocol, which sadly we can't because we decided to go in Postgres when the company started. But they have a really lightweight way of sort of forking a database and using that. I think that's the Galaxy Brain solution to this.
But you have a shared database.
A shared dev database, yes.
Shared dev database. But you're saying you want to push this further, and there's options including read-only prod, which has some maybe personal information caveats.
Yep.
Or forks that are how do the forks work? It's just like ad hoc.
Yeah, Snaplet is a cool company, and I haven't tried it in a couple of years, so maybe they've improved the performance of it too. But their thing is we take snapshots of your production database and we allow you to define functions basically on a per column and per table basis that allow you to anonymize the data. So say you have a table that has like name, address, you can in Snaplet go, okay, name, I'm going to pick a random for each row in here. When I snapshot, I'm going to take a random name from, and Snaplet gives you here's English names. Take a random name from English names, overwrite it, stick it in. Take a random address from English addresses, USA addresses, stick it in. And then when you get your dev snapshot, it's John Smith is the name, and 123 ABC America Avenue, Chicago, Illinois is the address. Those aren't the real addresses. You don't care. You just want 10 million rows as a backend engineer, I don't even necessarily care that they're real addresses. But for front-end people, it's really nice when you make the API call for user.address and you get an actual address back instead of a bunch of BS. It makes it much easier to design the page. So Snaplet is a cool approach to that, but basically making snapshots of your database, anonymizing the data on the way out to avoid the PII issues, and loading them in dev. The tricky part is if your database gets humongous, that takes longer. Actually, now I'm remembering, I think Snaplet has released a subsetting feature, so you can say, I'm going to express to you some sort of relationship. Like, I only care about rows that are related to this row through like foreign key relationships. Only snapshot like the replay team, and the replay team is associated with all these users, and those users are associated with recordings, and the recordings all have source maps and comments and logs and blah 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 blah, and it like figures all that stuff out, pulls it all in, and then that data is much less, probably at the cost of making the snapshot take longer. But that's not the hard part. For us, the hard part was loading the snapshot in. So that would probably be what I would try next.
So it's like if you have a multi-tenant database, you could just pick a tenant and say like, this is the one we want to use. And like follow all these foreign keys and just pull in this user because they're hefty, but they're not so big they're going to crush our dev box.
Yeah. And we didn't talk about S3. So a lot of our recording data itself, the thing that powers the time traveling debugger, that is a binary blob in S3 that's not stored in the database. That can be many gigabytes large. So we have a internal tool that allows you to import those binary blobs into dev. So basically copy from production to dev, and you have to attest with a like link to a thing that you asked for permission from the user and they said yes. Because our product does capture a lot. Our database is actually not that sensitive. It's URLs and comments that people wrote. But the recording data in S3, that could have cookies for bankofamerica.com in it that you accidentally included in a recording. So that stuff is super sensitive. And the S3 thing is a sort of whole other, what's the phrase? Not bag of worms. Bucket of worms? Is it a bucket of worms? That's funny because it's S3 buckets.
I don't know.
Can of worms. There we go.
Can of worms. There we go. Yeah. If you have, you have to figure out a way to separate those out too. That's interesting. Wow. You guys are really pushing the envelope of like a dev, I guess of like ephemeral environments, like ephemeral dev environments.
Super ephemeral. Yeah. Yeah. And we have to, because of the thing I said at the beginning. You can make these little 5-second recordings and run them on your laptop, but that, much like the database problem, is not indicative of the performance of the product for real user use cases, because A, that 5-second recording of the Hacker News login page is a fraction of the size of most user recordings, and B, your laptop is slower than the fastest EC2 instance, which are the only EC2 instances we use. So running things on your laptop, not very helpful. Like, because what we want to do is build products that work well for our users. And if we're not operating on the similar enough data to what our users use, nor are we running it on similar enough hardware to what our users would be getting serviced by, then we would make poor decisions.
Yeah. Wow. This is a tough problem, but you guys are doing it. That's awesome.
Earthly made it a lot easier. Like the whole cloud dev thing, it took me a week, like end to end. And I think I had it mostly working in a day. I was like, okay, satellites are a thing. Turn on satellites. The hardest part was that -- no output flag, realizing that would completely bypass having to upload images. And once I set that, again, actually because of the tilt file, right? People were running tilt up. And then one day I was like, hey, congratulations. You no longer need to run Docker on your laptop. You can just turn it off or uninstall it. Because tilt-up hasn't been using it for months.
That's awesome. I've had that same thing where I'm using Earthly and then I go to start something up in Docker. I'm like, oh, it's not running. Yeah. All right. This has been awesome. Thank you so much, Dan. Thank you, Replay.io, for kind of pushing this ephemeral environment to its natural endpoint.
And thank you for all of your help with this, because we've been in Slack communicating for years, probably. And whenever we come to you all with a crazy idea, you're the first to either help us do it immediately, which is usually most of the time, and tell us this is actually already possible, or have an extremely detailed GitHub issue that I always follow with great interest and almost always gets closed.